All right. So, does everyone have the quiz open?
Yeah, I attended. All right, bye. Just kidding.
Hey, let's let Nick answer number 2.
A.
Nice
Yeah,
job.
Okay. Number 3, researchers at a university of Mississippi want to determine males different from the females. Researchers so 20 females. The no goes. Wouldn't they be yes because it's a large enough sample size? So A, would they be able to apply the central limit theorem?
I said B.
I said B as well because all we know is that it's normal, and
Yeah.
each of those itself is not technically large enough to be considered central limit theorem status.
Why is that?
Because there's 20 females versus 50 males. Each of them.
Oh, so this is not combining the two?
Correct,
No.
yeah. Versus.
Oh, okay, that makes sense.
So each of those couldn't be under the central limit theorem, so I said B as well.
Okay. I thought you combined them, so you get 35, but...
Yeah, that question, there's a few of them that I was like, I'm glad we're having a group meeting because I don't feel too comfortable with some of them yet.
Yeah. As long as you have data to back it up like you just did, I don't care. Okay. Number 4. Of the 4 types of confidence intervals listed below, which are the most appropriate for this experiment?
I said D, or confidence interval for the difference of means.
Agreed.
Yeah, because they are independent of each other.
Yeah.
What do you think, Brandon?
That's what I put as well. Did anybody notice? Maybe it was just me and I screwed things up. There were a lot of D's on the answers for those things.
Yeah, there's especially like 13
He just
through like
wants us to
20.
read.
A lot of D's. All right, let's keep going.
Okay, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of random sample 30 customers. A 95% confidence interval for the mean savings account balance of the bank customers is found to be that number. Which of the following would produce a confidence interval with smaller margin of error that is 95% confidence interval? Okay.
For this one, I put B, but I wasn't 100% positive.
That makes sense because it's a huge number. But
Yeah, that was the only reason I thought it could possibly be is because it's such a big number. It would bring kind of the numbers together, if that makes sense.
Right.
So you're wanting to look to find a smaller confidence interval, so we'll need smaller margin of errors.
So you want more sample
You want
size.
a larger sample size.
So it'll be B.
Yeah. That's what I had.
Brandon, is that what you had?
That's what I had. I'm just trying to figure out which one this was. This was. Number 5. Can't gather my thoughts today.
That's how I felt when I was doing this earlier. I was like, I can't think. I can't figure out why it would be like that.
Well, I mean, even looking at it, you don't need to compute a 99% or that just make it worse.
Yeah.
And then only 10 customers is too small, so obviously you're just going to get bigger sample size. The end.
Perfect.
We good?
I think it's B just because it's the only one that kind of makes sense, and I don't think it's none of the above because having a broader amount of people is going to make
more sample size, more accuracy, so you can't go wrong there. All right, number 6.
Yep.
Okay, factory makes propeller drive shafts for ships. Quality assurance engineer of the factory needs to estimate the true mean length of the shafts. She randomly selects the 4 shafts made at the factory, measures their lengths, and finds their sample means to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. All right, so we're going 2. So we're going 9 Oh gosh, pardon.
I had A as the answer.
That's what I had.
Did
What
you?
equation? What equation did you use though to figure that out?
Well, I actually just
Well,
calculated.
isn't it B? Or am I totally off?
Yeah.
No, it's not B.
Yeah.
Oh yeah.
You have to calculate the z-score and then determine the margin of error based on that z-score because we have the standard deviation, we have what else? The sample mean. Like we can calculate the margin of error and then we just calculate it, the confidence
Okay,
interval.
yeah, that's what I did. I just want to make sure I did it right.
Okay, that makes sense.
Okay. 7.
7. To assess the accuracy of a laboratory scale, the standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the sample and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation 0.01 grams. How large should n be so that 95% confidence interval for u has a margin of error of 0.0001?
I said C.
That's what I put as well.
Okay, how did you guys find that one? Is that just plugging it into the applet?
It's actually not.
Okay,
we,
so that's where I went wrong.
we can calculate the margin of error with the z-score times the standard deviation over the square root of n, and we have the standard deviation, have the margin of error, so we can just go through and basically do some algebra. And we have our confidence interval. We know that we can just use the applet to find that z-score for that.
Okay.
Which is the 1.6 something, right?
1.96.
9.6. That's what I meant.
Yeah.
Got some memories.
Okay.
So that's what I did. Is that what you did, Brooke?
Yeah, that's how I figured it out. So.
Okay. That
And I
makes
like
sense.
step by step used the book because I was like, hey, I don't remember because like, we've done so much in these last few chapters that it's.
I just started plugging in the answers times. We're 12,000. Of course. You guys back? I
Yep.
cut out. Okay. Sorry. It's that quality internet they give us. Okay, the mean area U of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire blah, blah, blah. Okay, so it's not equal to, or actually it's smaller than. My bad.
Yeah, so it'd be A.
A.
Yeah. Okay. In a statistics test of hypothesis, we say the data are statistically significant at the level of significance alpha if it's lower than alpha.
Yep, so it's B.
Okay. 10. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data they collect for each apartment building are bell-shaped with no outliers, and the simple standard deviation are nearly equal. And they use an ANOVA hypothesis test to answer these questions. I said yes.
Yeah, I put the first one.
I put the first one too, but they're missing a part of it that's a requirement for the ANOVA test. And so I don't know if that changes or it shouldn't, but
What is it missing?
they have to be normal, and it has to, the standard deviations or the variances have to be equal. And in
Well, standard deviations are nearly equal.
and that's part of the answer in the book, but they took it out on this number 10. But it's still part of the answer you chose, the very first one. That's the one that I chose as well.
Did you just say there's answers in the book?
No, it's like it gives you the options in the book for the review.
No, I was like, what?
the one that we would
Yeah.
choose here is, yes, it is enough
Randy,
that the data are
bringing
Bell
us along.
shares and the sample deviations are nearly equal. So
Yeah.
there's the requirements. I mean, the first one's the only one I can think of. The rest of them really don't apply.
I don't think any of the other ones would make sense. Because it doesn't have anything to do with the total of 60 GPAs, does it?
I don't think so.
And they have a significant amount of data, enough
Yeah,
to
I mean,
make a difference.
Yeah, because they're comparing the apartment buildings, and so each sample size is technically only 15. So you couldn't do the central limit theorem.
so that's out of. And you
They
can't
have-
put no because they do have enough data, and because it was normal.
Do we know that it's the standard deviation of the sample, or does it have to be the true standard deviation for that one?
Are we looking too deep?
For ANOVA.
For ANOVA, right?
Yeah.
Yeah.
My computer will load. Come on.
Requirements
We
of
can
ANOVA.
definitely the test and we follow
All
two
things are
requirements.
equal, this one means different. Relation.
I'm sticking with A. That's good enough for me.
I think the only other
That's my
thing that
best
threw me off
guess
is
too.
I mean, if he gets really technical, and then I'll be confused.
Okay. Do you want to mark like 10 and we'll come back to it?
yeah, we'll come back to that if we have time. All right, 11.
All right, I'm not reading that one. That's too long.
Treat it to yourself.
I'll do short questions just so we're on the same page. Oh shoot, I can't remember the type errors.
The type 1 error is committed when we reject the null. And type 2 is committed when we fail to reject the null.
So this one's a type 1 error, right?
Yeah, I said it committed a type 1 error.
That's why I put down 2.
Because she rejected the null, so.
And what does it mean, like when in the like that square that had like the 4 different options?
Yeah, that's that part.
What?
Something, I don't know.
Was our exam last time all multiple choice?
Yeah.
Okay, good. I hope this one is too.
Well, actually, no. I think the other one was like using.
I'll look.
No, our last exam we had several open response because remember I didn't explain it to you. I had some confusion with the
Oh, we
decimal
did
places.
because we had like you and I struggled with with some of them and putting them in. Okay, yeah. Like the first half was all multiple choice, or not multiple choice, fill in the blank.
I think it'll be the same though.
With those with number 11 real quick, C and D, I didn't understand C at all. Does that make sense to you? Like nowhere in there does it say that she should use a 0.01 significance level, right?
No.
And then incorrectly use a 0.5 significant test when she should have computed the p-value. Like you have to compute the
p-value. The only thing it says about the significance level is that it's just significant. That is really hard, or statistically significant. And then I don't think she would have to compute the p-value.
Well, I mean, don't you compute the p-value every time anyway? Like you compare the two, you don't have to replace one or the other.
No, you don't have to replace it at all.
That's what I was confused about. I was like, what? That's dumb questions again. Okay, I'm ready for 12.
Oh, okay. All right, the level of significance alpha is made small, thereby making a probability of committing a type 1 error very small. What happens when probability of committing a type 2 error?
I said by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2.
That's what I got.
Agreed.
Based on what that box says.
Yeah.
The magic box of knowing. All right. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams U and a known standard deviation sigma equal 0.17. The brand advertises that the mean nicotine content in the cigarette is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar being 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
I had reject the null after I did my calculations.
Yeah, I said fail to reject.
You said fail to reject?
Yeah. So,
Did I plug it in wrong?
I don't know. How did you... Let's see here.
So you're going to take X bar minus the assumed mean, which is 1.53 minus 1.5.
Yeah.
Then you're going to divide that by the standard deviation over the square root of the sample mean.
Okay, let me see here.
Sample size, excuse me. And all that's going to do is give you your z-score. And then you take that z-score, plug it into the normal probability applet, and shade the right side.
Okay, give me just a second here. Let me redo this.
And you shade the right side because it's larger than 1.5?
Correct.
Okay. I remember I questioned that before, and you knew the all-known answer.
Okay. Maybe it is reject.
Did you agree? Did I do something wrong? Like, I just want to make sure we're all on the same page before we...
Because, let's see here, it's 1.5, is that right? Or we plug 1.5 in and then I'm going to put probability applet too.
No, so we have to calculate the z-score and plug that into the applet.
Okay, I did that, but how do we know what the null, or the...
P-value?
Yeah.
You're going to look at your alternative hypothesis, and it says that we're looking for anything greater than 1.5, so anything greater than that z-score. So you're just going to shade the very right tail, and that will give you a p-value of that probability.
Okay. So I'll change it to reject then. That makes sense.
Okay.
Forgot how to use that thing for a little while. I had to go back
You would
to
like
some
to
old
look
stuff.
at the mean number of hours worked for wages per week by male students. Different. What statistical procedure? Paired sample t-test?
I said independent sample tests, or t-test.
What'd you say it cut out?
Independent sample t-test?
That's what I said
Okay.
too.
So correct me real quick. Independent, it's two different groups, male and female, correct?
Mm-hmm.
And so even though they're looking at both the same hours, it doesn't make the men or the male or female population dependent of one another.
No. They're they're looking at two separate, like, statistic outcomes.
It would be paired if they were to say something like wages per week by male students and female students in a relationship or that are couples or married.
Okay.
If they
But
somehow bonded them
they're
together,
students.
then it would be kind of you take one, you take their spouse as well.
I gotcha.
They're just random. They're not related.
Independent of each other. All right. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother and sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? Wouldn't this be dependent then?
Yep.
Okay.
So I picked D on that one.
Yeah, so did I.
Okay. You guys unfogged my judgment cloud from 14 and 15 now. All right, 16. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The researcher would confidence interval for the mean dissolved organic carbon level in the field. Open the data file that I don't want to open right now and use the information to question 16 and 17. Oh, data carbon. Oh, I love you. What the freak is it called? Dissolved. Cool story. So, okay.
So for 16,
Are we just doing a one sample t-test?
yeah.
Okay. That's what I thought. Options, 95%. Do we use the test value? No, we don't have that information. Alrighty.
So for 16, I said the
I got
confidence interval for
11.1.
mu when the standard deviation is unknown. Sorry.
Yeah, that's what I put too. For unknown.
That's the rule. And then 17's D. As in cat.
Yep, that's what I got.
Alright, cool. A random sample of Hummers for sale in LA and New York were taken from listings at cars.com. We want to know if there's a difference in mean listing prices between Hummers in LA Group 1 and Hummers in Sale Group 2. Create a 95% confidence interval. Okay, got to open up more of that statistical goodness. Used Hummers. Dude, I freaking love SPSS. SS. Yes. So convenient. Don't tell me which one. Are we doing independent samples t-test?
Yep.
Yes. Didn't mess up. Well, we have to recode.
Forgot how that one was set up.
Oh, wait a minute. Hang on, I just opened bone mineral density.
Yeah, I think that one was set up where you have to do the automatic recode because it's all in one column for the data. And so you keep the cities that they're from, and then you keep the dollar amounts, and then you can recode for LA and NY.
Okay, so we want correct.
Do what?
We want to recode the city?
Yeah, you want to recode the city.
Okay, that's what I thought. City, recode, places. Add new name. Oh, okay. I'm doing price. That's still 95%. Groups 1 and 2. Continue. Okay. Okay. I got my information, I think. Are you guys good?
Yep.
Yep. So for 18, do we all agree it's D?
Yes.
Okay.
I agree.
And for 19, what did you get, Nick?
I got 4. So C.
That's what I have as well.
Yeah,
Because
that's
we
what I
always
had.
use the one not assumed, correct?
Correct. Yeah, I always not assume them. That's very cool.
Okay. That's what I thought. Okay. Between exercise and health. The data.
Come on. My thing's not working.
As soon as I see the new questions, I'm just like, no, you're not. I'm just gonna look at the data. Okay, everyone has the data open?
Yep.
All right, I'll finish reading it. Exercise stress on the bones that cause them to grow stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups: rats that were selected at random, the control group with no jumping, a low jump group. The jump height was 30 centimeters. The high jump group was 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats, expressed in milligrams per centimeter cubed, were measured. The rats were selected at random for the 3 groups. Researchers would like to determine if the mean levels of bone density are different between the 3 groups of rats. Awesome. So then our level of significance is 0.05, and let's see what happens. Now that we have, gosh, ANOVA tests. Okay, is this one ANOVA?
Yes.
Yes.
Okay. So then I have to freaking recode again. Treatment. Doctor. That's what we call it. Laws contains ANOVA. We're at 95% again. Alright. Okay. What is statistic?
So remember that the test statistic for an ANOVA is the F.
Oh, wait a minute. It'd be nice if I didn't open the wrong one. Recode. Okay. I got C.
That's what I got.
Agreed.
Sorry that took so long.
You're okay.
Okay. And then the p-value is B.
Mm-hmm.
Okay, which of the following best expresses the conclusion of the test? Since the p is low, there is sufficient evidence to conclude that at least
I
one
said
group...
B.
Yeah, that's what I was reading. Or attempting to. We'll just go with the short answer, B.
Okay.
Alright, let's open the next one, direct flight costs.
So I had some trouble with this one, and maybe y'all can help me out and figure out what I'm doing wrong.
I'll help you.
Okay, let me open it.
Gotcha. Okay, first off, we're doing ANOVA test again.
For the direct flights, you're going to have to do the differences column, and it should be a one sample t-test off that differences column. Or you can do the dependent samples test just off the two columns. But I couldn't get any of the answers. Like everything I pulled up, all my data never matched anything they gave me.
Let's make it up.
They're the same thing.
Okay, so when we're computing the variable to get the difference, we're moving over 90 days minus 14 days, right?
Correct, yeah. It should be final minus initial, so.
That's what I did. Go. Okay.
How do you make that one again?
So if you go to transform and then compute variable.
That's okay. That's my button. And then I go 90 minus 14. Enter.
What the heck?
So wait, what do you do after you put 90 minus 14?
You're going to have that differences column there. And then you should be able to run a one sample t-test off of that.
Okay, mine won't let me do it this time.
Oh, I forgot to put in a name difference.
I put in the name and mine's still not doing it.
Alright. So I got my differences, and then I run... Did you say one sample t-test?
Yeah, one sample t-test off the differences column only.
Okay. Did you put in the test value? Did you change that?
I didn't because it didn't give us anything to compare it to. It just says
Okay.
it's different.
Got $10 somewhere, and you changed the 95 to a 90, correct?
Yep.
I bet it's the test variable, which...
I would help, but mine won't let me do the differences for some reason this time.
Didn't yours do that last time also?
Yep. It's being
What
a
a-
pain in the butt.
ESS.
For column 13, row 13, whatever it is, in 90 days, do you guys have anything under that or no?
There's nothing.
Okay,
There's nothing to be compared to.
that's what I thought. I just wanted to make sure.
Do we need to add that in, though?
I put
No.
zeros in mine,
Okay.
and I tried it without it. I don't think it made a difference because it automatically takes it as a 0.
Okay, I'm gonna try to
I'm just trying to
find...
figure out why mine won't let me do the differences now. Because I'm minusing them, subtracting them.
I'm minusing so hard.
Okay. No, it says one of the operands for an arithmetic operation is other than a numeric variable or numeric expression. What are you talking about?
It did that to me before. Last time I tried
I
SPSS.
figured it out.
What?
It copied over my 14 days and 90 days, like the actual writing. So if I just clear that, now let's try it. Stupid me. There we go. Boom. Okay, and then, okay. Nope, never mind. Now it's not doing it. Okay. Boom.
Oh wait, do we have a mean?
No, that's what I'm saying. We don't have anything to put in the test volume area.
Oh wait, would we have to do another one of those tests?
What about a dependent sample test?
That's what I'm asking.
I think I realized what I did wrong.
Okay, because I did a dependent sample test when I was able to do it, and
What I had done is I just assumed that we were supposed to put zeros in where those blank spaces were, but you
Oh,
have to leave them blank in order to get their answers.
Right.
And so I didn't. That's what I was doing before, is I was putting in the zeros, and so I just tried it without it, and I got one of the answers that they have. So that makes sense.
So wait, what'd you put as the test value? Just blank?
Yeah, I just left it at 0.
Oh. Oh, I was like, I have to
Nice.
put something there, and I guess you just put it there. Yeah.
Stop.
1685.
So
As
you got
a
1.685.
statistic. Yeah. But mine's so.
Okay, so it says, what is the correct hypothesis test for this situation? Technically, it's a dependent samples test, right?
Yes.
Even though we're going to use a one-sample t-test on the differences column, we can calculate it with a dependent samples test.
Yeah.
Yes.
And the p-value should be 0.096 then? Is that what you guys
That's what I got.
Yes.
Oh, wait, no. Yeah, because you don't divide this one, duh. And you guys are cool with the 25 being 1.685 even though it has a negative on it?
Yeah.
Okay.
I mean, I think the only thing is I hate it when they do this. They don't clarify exactly which one to subtract, but I think all it does is reverse the signs on that.
Well, it's usually it's like P2 minus P1 or whatever, so like whatever numbers the 90 days would be subtracted from the 14 like you had originally. So I think you're right regardless.
Yeah.
Well, that's the number, so that's what I'm going to put.
Yeah. I mean, it gives us everything else correct, so yeah. Okay, and then our p-value is low. Or no, yes.
Yeah.
Well, do you round that up, or is it just as it is?
It's just as it is.
Okay. So there is sufficient evidence to show that there is a difference in cost. Is that what it is, B?
I said D.
Wait, P is low, reject the null, insufficient. Yeah, sorry. My bad.
Hey.
But, let's see.
Point.
Huh? That was class.
Boring.
Why did you say D?
Well, I don't know if it's right because alpha's 0.1. Hold on, I'll have to look and see what I did here.
We should reject the null. I'm just trying to figure out what the null hypothesis actually is.
It's just the two-tailed thing, isn't it?
That's the p-value. Like, what statement are we rejecting? Is it the fact that they're different, or are we saying that they're the same and we're testing to see if they're the difference?
We're saying that whether there is or is not a difference.
I thought that the P was low, you reject the null, so there's sufficient evidence.
Because that's what I think is.
Or am I getting it all backwards?
I'm just going
I
back
put
to
B.
what null versus alternative is.
Maybe you're right. I don't. Let me think. I guess that makes sense that there's sufficient.
Oh my gosh.
Yeah.
Why?
Yeah, so it looks like we're testing to see if there's a difference. So that's our alternative hypothesis, correct? If we're testing for it. And so we would reject the null, which would be the fact that they're the same. So there is sufficient evidence to say that there's a difference.
So we're gonna go with B then.
That's what I put.
Okay, that makes sense.
Yeah, I think that's what it is.
Okay.
This is the way I remember it. P is low, reject the null, it's sufficient. Alright, who wants to read through the answers?
I can. Hold on.
Oh, right.
Okay, 2, we're gonna go.
Just kidding.
Okay, well, your 1's up to you, but 2 was A. You guys care if I do that, or do you want me to read out the whole answer?
That's fine.
Okay. 3 is B. 4 is D. 5
Okay,
is
hang on.
what?
I keep cutting out. 2 is A, 3 is B.
Yep. 4 is
Okay.
D.
Okay.
5 is B.
Okay.
6 is A. 7 is C. 8 is A. 9 is B. 10 is A. 11 is A. 12 is D. 13 is A. 14 is D.
Wait, hold on. Go back to 13.
Yeah.
13 is D. You're rejecting the null, not the alternative.
Oh, my bad. Sorry. But the other thing with that is, I think why I originally said fail to reject is because when you do it, it comes out as 1.75 instead of 1.5, so it's greater. But then when you put it in the normal probability applet, I saw where you're coming from.
Yeah.
So anyways, okay. So we're rejecting the null, right?
Yep.
Okay. 14 is D. 15 is D. 16 is B. 17 is D.
15 is
18 is what?
15 is B or D?
D, as in dog.
Oh man, this lag is so good.
Okay, 16, B as in boy.
Yeah.
17 is D. 18 is D. 19 is C. 20 is E. 21 is C. 22 is B. 23 is B. 24 is C. 25 is A.
Wait,
26
24 is C?
24 is C, yeah, dependent sample tests. 25 is
Okay.
A. 26 is B. And 27 is B.
So even though we did a hypothesis test for 24, it's a dependent samples test.
Yeah, just because the data itself is related to each other, like the beginning
Right.
90 days is related to the 14 days. We technically ran a one-sample t-test on the differences, but essentially what we did by doing that was a dependent sample test.
Okay, so that's what you were saying before.
Yeah. So we did it a different way, but the technical way is the dependent samples because they're related to each other.
Okay. Because there is no such thing as a dependent samples test.
Yeah, it's called, what do they call it in SPSS? It's like the paired samples t-test.
Yeah.
But they reference it back and forth in the book, I think it is.
So if we did a dependent samples test, why... Okay, hang on. Sorry, guys.
Maybe.
Why did we do a one sample when we could have done an independent sample? Just because they are dependent on each other since it's light?
Yeah, so to do the dependent sample, you would use the direct information from 14 days and 90 days. With the one sample t-test,
Okay.
you make the difference column, and that's the only thing you care about is the differences, and you just void out the rest of it. Because really what that paired sample t-test does is it calculates the differences and then does a one sample t-test on the differences itself. So it skips a step.
Okay.
The book teaches us to do the one sample t, so that's the one I did.
Okay. I'll take your word. I mean, we got the answer, so it obviously was the right test.
Yeah.
All right, cool.
I was curious about that too. I don't really know. Because I think they had that on like the homework question, didn't they, as well? Like dependent samples test.
Yeah, I think so.
Was that last one or the one before? One or the other. I don't know. Maybe last week's, but yeah. Yes, dependent sample t.
Or group thing, or you have to go, don't you, Brooke?
We can talk about it for a minute. What time is it? Actually, no, we can't. I didn't even see what time it was. Okay. Did you guys have an idea about it at all, or?
Why don't we text back and forth this weekend? Maybe narrow it down so that way when we get to Tuesday we can already have it planned out.
Okay, why don't we all come up with like
Okay.
2 or 3 ideas and then just kind of choose between those?
Okay, sounds good.
Yeah, because it has to be done